Hello, good morning, and welcome to day one, part one of review. You should be at the top of your packet on scientific notation under the section where it says watch on Google Classroom. We're going to go through these 4 practice problems first, and then you're going to try a few on your own. Now, reminder, scientific notation just allows us to rewrite numbers, either really, really large numbers or really, really small numbers, so it makes it a little easier for us to read them. Now, if I'm looking at this number here, I see that I have a really, really, really large number, which means my decimal point is at the end of the number. Okay, if I have a really, really large number, then I am going to move my decimal point to the left to make it a smaller number. And I'm going to move it 1, 2, 3, 4, 5, 6 times. So that's going to give me 6.7 times 10. And again, I moved 1, 2, 3, 4, 5, 6 places. And I went from a really large number to a really small number. So my exponent here is going to be positive. If I go from a really large number to a really small number, my exponent will be positive. On this one, I am at a really, really small number. See, my decimal point is here, and I'm going to a really, really a larger number. So I want to move my decimal point to the right to make my number larger. So that's going to move this 1, 2, 3, 4 spaces. So I've got 1.3 times 10 to the negative 4th. Okay, if I start with a really small number, I'm making it into a larger number, my exponent has to be negative. Notice here that the decimal point, there is always just one number to the left of the decimal point. There should always be just one number to the left of the decimal point. All right, now we are going the opposite way. We're given a number in scientific notation, and we have to write it as a number or an expanded number. Here I've got 4.5 times 10 to the 4th. Because my exponent is positive, I know that this is going to be a really, really large number. So I'm going to write this as 4. Okay, and then I move my decimal spot 0.1, 2, 3, 4 places. So 4, 5. So that counts as one of my decimal places. 1, 2, 3, 4. Okay. Now notice here that we only have 3 zeros. That's because we had to take up one of our spaces moving past this 5. Okay, so this number doesn't mean add 4 zeros. It means move your decimal point 4 places. Okay, our very, very last one for this practice section, I've got 5.1 times 10 to the negative 3rd. This exponent is negative, which means that this is a really, really small number. So I have to move my decimal point to the left 3 spaces. So I move it 1, 2, 3. There's my decimal point. Any blank spots I fill in with 0. So I've got 0.0051. Okay. If you want to add a 0 to the front of that decimal point, you can. Again, notice that I only ended up with 2 zeros here, even though my exponent was 3, because I had to take up one of my spots moving past the 5. Okay. What you are going to do next is pause and practice on these 4 problems below. When you are done with the pause and practice, you are going to go to day 1, kind of part 2 here. Day 1, part 2, which is these notes on Google Classroom. So once you finish those practice problems, we are watching the video on these notes. Now, this is a mock external assessment problem, so very, very similar to what you will see on the test. And this one is just the skills we learned before, just in a slightly different format. Okay, so here it says consider numbers P equals 2.78 times 10 to 11, and Q equals 3.12 times 10 to the negative 3rd. It says calculate the cube root, that's what this little symbol is here, it looks like this, I know it's kind of hard to read, of P divided by Q. Give your full calculator display. Okay, well I know that P is equal to 2.78 times 10 to the 11th, so I'm going to plug that in right here. And I know that Q is equal to 3.12 times 10 to the 3rd, so I'm literally just going to pop this in my calculator. I like to write out what I'm going to pop into my calculator first, makes it a little easier for me. So I've got cube root, and then I've got 2.78 times 10 to the 11th over 3.12 times 10 to the negative third. Okay? When you are putting that in your calculator, go to calculate. See if we can see this here. Kind of, sort of, maybe not. The button you first want to press is down here. It's control, and then the little exponent up arrow. And then you can type in a 3 on the outside of that, what's left. So you press 3, and then I always set up my fraction bar first, so control, and then the division sign to set up your fraction bar. And I'm just going to type it in exactly as I see it. 2.78 times 10 to the power of 11 and 3.12, whoops, forgot to put that in the bottom of my fraction, 3.12 times 10 to the power of negative 3. I'm going to press enter, and I get this value here, which should be 44664.6. Okay? And then I've answered part A. Then it says write down your answer to part A correct to 2 decimal places. Notice here that we only have 1 decimal place, so all that means is add a 0 to the end. So I'm going to write this as 44664.60. Now I have 2 decimal places. The very last one is the most scientific notation oriented. This says write your answer to part B in the form A times 10 to the K, where 1 is between A and 10, and K is all real numbers. What in the world does that mean? All this means you can cross through this and just write your answer in scientific notation. That's all that means. It's a whole lot of words and symbols just to say write it in scientific notation. So here's my answer. And I know that this is a really, really big number, so I need to move my decimal place to the left. So I'm going to move it 1, 2, 3, 4 places to the left. That's going to give me 4.466460 times 10. And I started with a really, really, really big number, so my exponent is going to be positive. Okay, this is another moment where you are going to, if I can find my sticky note, pause and practice. You are going to pause and practice the example problems on the next page at the top. And when you are finished with those, we are going to move on to day 1, part 3. Oh, that says 2, but I meant 3. To our percent error problems. Okay, so looking at these, remember calculating percent error is essentially figuring out by how much is our answer off, or by what percentage are we incorrect. Okay, we need to know 2 values to figure that out. We need to know the approximate value and the exact value. So our formula is down here. VA is our approximate value. It is our guess. While VE is our exact value. Okay, it's the calculated exact value. And our formula is here below, the absolute value of VA minus VE divided by VE times 100. That times 100 is what gives us our answer as a percentage. It says Daniel estimated that there would be approximately 45 Takis in the bag he got. So if I'm labeling this, I see approximately, I know that that is my VA value. So VA is equal to 45. There were exactly 40. Okay, so that means my exact value is equal to 40. From there, I've got my approximate and exact value, so I'm going to plug it into my formula. It's absolute value of 45 minus VE, which is 40, divided by VE, again, which is 40, all of that times 100. Okay, And then I can pop that entire thing into my calculator. Couple buttons that we want to look at. To get those absolute value bars here, press this button under the delete button, and the absolute value bars are the second ones down in the first column. So you're going to click enter, and then set up your fraction bar. Fraction bar 45 minus 40 over 40, all of that times 100. And I got a fraction, so I'm going to convert that to a decimal by putting a dot in the denominator, and that gives me 12.5%. Okay, and that is my error. It's a 12.5. That means I was, with my estimate, was 12.5% incorrect. Okay, you are going to now pause and practice the two problems underneath that. When you are finished with these two problems, resume, no, I can't get the sticky note off, resume the video watching these notes on Google Classroom. So this is the very last problem that we are going to go over together today. And again, we've just learned the skill for this one. These words, they seem a little bit confusing and the question seems long, but you already know how to do the math on this. Okay? This says, each year, the soccer team Peterson United plays 25 games at their home stadium. The owner of Peterson United claimed that last year the mean attendance per game at their home stadium was 24,500. The actual total attendance last year was 617,700. So actual means that this is our exact value. Okay, and this is our approximate value per game because it is a guess. Okay, for a total of 25 games. So question 1 says, based on the owner's claim, calculate the total attendance for the games at Peterson United home stadium last year. So based on the owner's claim, that means we're using our approximate value. And I know my approximate value was 24,500, okay, for each game. And there were a total of 25 games. So my total attendance, when I pop that in my calculator, would be 612,500. That is our approximate value. Okay? Then it says calculate the percentage error in the owner's team. Well, lucky for us, we just calculated our approximate value, which is one that we need, and we were given our exact value. So our approximate value is 612,500. Our exact value is the value given up here, 617,700. Okay? And then we plug them into our formula, which is on the page before, but your formula looks like this. It's VA minus VE over VE times 100. So I'm just going to pop that into my calculator. First, I'm going to plug it into my formula. VA is 612,500 minus VE, which is 617,700. All of that over VE again, which is 617,700 times 100. Okay, so I'm going to pop that in my calculator. Again, to get those absolute value bars, you press this button underneath the delete key. Absolute value bars, set up the fraction, 612,500 minus 617,700. All of that over 617,700 times 100. Again, gives me a fraction, so I'm going to convert that into a decimal, and I get 0.8418%. Okay, and we've got one more part of our question here. It says, write your answer part B in the form A times 10 to the K, where 1 is less than A is less than 10. Remember that this really just means write your answer in scientific notation, which we just did before. Tific, can't spell. Okay, so I've got my answer here of 0.8418. This is a really, really small number that I want to make into a larger number. So I'm going to move my decimal point 1 to the right. Okay, and because I started at a really, really small number, it's going to be 8.418 times 10 to the negative 1, because I started as a really, really, really small number. And that is my final answer. Okay, you are now going to, I guess you could turn the video off at this point, but you are going to practice the practice problems right underneath that, and then you are done for the day. That's it. Like and subscribe.